NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of it and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the Sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that? In September 1859, scientists observed the first confirmed powerful solar flare. The Sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the Sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problems for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the Sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar-charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies would go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the Sun increases every year, then we'll have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the Sun are similar to this tousled hair. When the Sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the Sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the Sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the Sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere. On July 23, 2024, Europe's Solar Orbiter spacecraft observed a super-powerful solar flare erupting from the far side of the Sun. This flare wasn't the most extreme ever recorded, but still, we got extremely lucky this time not to get fried by it. Such solar flares often cause long-lived, raging radiation storms, and if such a storm moves in the direction of Earth, it can lead to worldwide blackouts. Before we go deeper into details of that potentially disastrous solar flare, we need to figure out what exactly this solar phenomenon is. Solar flares occur because the magnetic fields in the atmosphere of our star are moving non-stop. When the Sun is approaching its solar maxima, and that's the most active period of its 11-year-long cycle, which is, by the way, exactly what's happening now, its magnetic fields get more and more tangled, making our star look like an enormous ball of tangled rubber bands. They loop around, cross over one another, cut one another off, and then reconnect. Ever seen iron filings sprinkled on a bar magnet? These filings line up along the magnetic lines of force. Like that, the hot plasma on the surface of the Sun is at the mercy of the magnetic lines of force. Sometimes, when the magnetic fields interact with each other, some plasma gets disconnected from the fields, and its particles accelerate to immense speeds and send powerful radiation to space. That's what a solar flare is. Other times, our star throws off massive amounts of matter. Those events are coronal mass ejections, CMEs. Just one CME can contain as much as 20 billion tons of material. If that material were rock, it would create a mountain about 2.75 miles across and almost a half a mile tall. The ejected material often travels at a speed of over 1,000,000 miles per hour. Solar flares and CMEs are the most powerful explosions in the solar system. releasing unimaginable amounts of energy. Solar flares have their own classification according to their strength. The smallest and weakened ones are A and B class. Then there are C and M class solar flares, and the strongest are X class flares. A number from 1 to 9, and in some cases a larger one, accompanies each letter. That's similar to the Richter scale for earthquakes. A and B class flares are too weak to affect our planet. As for C class flares, they may have small, noticeable consequences. M class flares can cause short radio blackouts at the poles and weak radiation storms that can still harm astronauts. But the most dangerous of them all are X class flares. These are flares more than 10 times more powerful than X1. That's why the classification of X-class flares can go higher than 9. Now let's get back to that recent solar flare. It was X14 Class 1. Now we already know that it means it was an extra strong flare. Other large flares astronomers have detected recently include an X12 solar flare that happened on the 20th of May and an X10 flare that occurred on the 17th of July. All of them have come from the backside of the Sun. If we talk of the Earth side of our star, the largest solar flare that has been recorded so far within this solar cycle happened on the 14th of May. It was an X8.7 flare that led to radio blackouts, and a strong geomagnetic storm leading to magnificent auroras all over the world occurred a few days earlier. Powerful coronal mass ejections accompanied this storm. As for the July X-class flare, it was so powerful that it could have ended up tragically for us. Luckily, all that magnetically charged plasma blast that accompanied the flare didn't travel in our direction. If it had, it would have been quite the solar storm. Auroras would have been incredibly impressive and a wee bit terrifying in their magnificence. But at the same time, such a dynamic blast of energetic particles hurtling our way could have caused major technological problems and electrical blackouts, like the event in 1989, which severely harmed Quebec's power grid, or a much earlier catastrophe that still managed to cause a lot of harm to the world. I'm talking about the Carrington event, which occurred in 1859 and was the first documented solar flare affecting our planet. It happened on the 1st of September and was named after Richard Carrington, the solar astronomer who witnessed the flare through his own telescope and sketched the Sun's sunspots. According to scientists, that flare was the most powerful documented solar storm over the last 500 years. The Carrington event triggered auroras that were visible as far south as the Caribbean. It led to severe interruptions in telegraph services all over the world, even shocking some telegraph operators and sparking fires after discharges from the lines ignited telegraph paper. Another major solar flare that erupted on the 4th of August, 1972, destroyed long-distance phone communication across a few states, including Illinois. This event even made the American Telephone and Telegraph Company redesign its power system for transatlantic cables. Now let's move to March 1985, when two super-powerful CMEs triggered a geomagnetic storm, which, in turn, set off a power blackout in Canada on the 13th of March. This blackout left around 6 million people without electricity for 9 hours. It is said that the flare disrupted electric power transmission from the Hydro-Quebec generation station and melted a few power transformers in New Jersey. And still, this solar flare was nowhere near the power of the Carrington event. The Bastille Day solar storm took its name from the French national holiday because it occurred on the same day, on the 14th of July in the year 2000. It was an X5 class event that caused some satellites to short-circuit and resulted in radio blackouts. It's still one of the most highly observed solar storm events. From October to November 2003, our star unleashed a series of large solar flares and coronal mass ejections, and they did reach Earth and slam into our atmosphere. Those solar storms, also known as Halloween storms of 2003, caused aircraft to be rerouted, impacted satellite systems, and led to power outages in Sweden. Besides, the Solar and Heliospheric Observatory couldn't fulfill its functions during this solar onslaught. On the 28th of October 2003, the Sun sent a whopper of a solar flare our way. The fire was so powerful it overwhelmed the spacecraft sensor that was measuring it. The sensor topped out at a whopping X28. But later, scientists figure out that the flare had reached a peak strength of about X45. One more thing that made the Halloween storms so scary was that they happened during a time in the solar cycle when solar activity is usually quiet. That's 2 to 3 years after the solar maximum. According to NASA's statistics, just 17 powerful flares erupted from our star during that time. The Sun spewed out another X-class solar flare on the 5th of December 2006. It was an X9-class flare that disrupted satellite-to-ground communications and GPS navigational signals for around 10 minutes. That solar storm was so powerful it even damaged the Solar X-ray Imager instrument on the GOES 13 satellite. It sustained damage to several pixels of its detector. In February 2022, SpaceX experienced the terrifying power of our star when a devastating geomagnetic storm destroyed 38 Starlink satellites worth tens of millions of dollars. It happened shortly after they were deployed. Unfortunately, Starlink satellites are especially vulnerable to geomagnetic storms since they're released into extremely low-altitude orbits, between 60 and 120 miles. They also rely on their onboard engines to overcome the drag force and raise themselves to their final altitude of around 350 miles over the surface of our planet. The thing is, during a geomagnetic storm, Earth's atmosphere absorbs energy from the storm, heats up, and extends upwards. It results in a denser thermosphere, which means more drag, and it can be a serious issue for satellites. That's exactly what happened. The batch of newly released Starlink satellites didn't manage to overcome the increased drag and started to fall back, eventually burning up in the atmosphere. At first, it may seem like the Sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The Sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, 2 teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft, designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white, and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole, a blank void with no galaxies, stars, planets, or asteroids, literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Boötes Void. It lies in the constellation of Boötes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing, but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Boötes Void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri E. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri E is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet, Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical, pun intended, of course. It's 26.9 nonillion, and if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, one of the most expensive diamonds on Earth ever is the Cullion. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later it was cut into many small diamonds. The largest of them is Cullion 1, which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the Diamond Planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of this structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly, super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DGSATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1. Makes sense. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the Sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the Sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the Sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, It makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered. Well, we've been miscalling Uranus all this time. Actually, astronomers say we should be pronouncing it like Uranus, not Uranus. I can't say a different stress changes much, though. However, things could have been different. Initially, Uranus was supposed to have the majestic king-like name of George, because astronomers wanted to name it after King George III. In the end, they changed their minds, and now, well, it's the punchline of every joke. If you take the total cost of launching a mission and divide it by the weight of the cargo, you'll see some pretty mind-blowing figures. According to specialists, back in 2016, it used to cost $10,000 to send just 1 pound of cargo into space. But now, prices have gone through the roof. Cygnus spacecraft's cargo costs over $43,000 per pound, while SpaceX's new carriers come in at around $27,000 per pound. Remember how hard it is to pay $5 for water at airports? Now, a bottle of water in space would cost somewhere between $9,000 and $43,000, and that's only to have it delivered in space. Now, as for water in space, well, it used to be considered a super rare thing. But in reality, there's water ice all over our solar system, so you don't have to buy those overpriced $43K water bottles. It's hanging out there in comets, asteroids, and even in hard-to-see craters on Mercury and the Moon. We're not sure if there's enough water in these places to support colonies of people, though. Mars also has ice at its poles, hiding under the surface dust and frost. Even smaller celestial bodies, like Saturn's moon Enceladus and dwarf planet Ceres, have ice. NASA scientists think there might be a chance of finding life on Jupiter's moon Europa. There might be liquid water beneath its icy shell. Europa, even though it's a lot smaller than Earth, might have an ocean deep enough to hold twice as much water as all the oceans on our planet combined. In 2009, scientists exploring a massive cloud of dust and gas in the center of our galaxy stumbled upon a fascinating surprise. They found ethyl formate within the cloud. This chemical is responsible for the delightful flavor of raspberries and has a rum-like scent. Furthermore, another nearby region is brimming with ethyl alcohol, the same type found in many beverages. In fact, there is enough alcohol in this region to provide every person on Earth with 300,000 pints of beer every day for the next billion years. Now, believe it or not, we do have a black hole on Earth. The thing is, creating an in-lab black hole was a sort of indispensable thing to do. Studying black holes in real space remains a distant dream, so it was only possible to create one to experiment with in a lab. A group of scientists in the Netherlands wanted to explore the mysterious Hawking radiation theory proposed by the iconic Stephen Hawking. Using atoms to mimic an event horizon, they orchestrated electrons, causing a surge in temperature that resembled flat spacetime. As particles moved through quantum fluctuations, a ring of infrared radiation appeared around the lab-grown black hole, mirroring Hawking's idea. So, if you totally understood what I just said, could you please explain it to me? Now, it may sound insane, but you can totally be allergic to the moon. Long story short, it was the final Apollo mission, and they brought back more rock samples than ever before. Plus, they had the first and only pro-scientist on the moon, Jack Schmitt. He was a geologist, and his rock samples helped scientists learn more about the moon's magnetic field and volcanic history. During the expeditions, it became evident that Jack Schmitt was allergic to moon dust. The gritty, sticky powder clung to his suit and his skin, causing irritation in his sinuses, nose, eyes, and throat for a couple of hours after he took his helmet off. Meanwhile, neutron stars are extremely dense, being basically just a bunch of neutrons squished into a super small space. If you had just a teaspoonful of this stuff, it would weigh more than the entire human population combined. And to match the density of a neutron star, we'd all have to squeeze into the space the size of a sugar cube. No thanks. When it comes to outer space, we tend to think that Earth and the Moon are pretty close together. But in reality, you can actually squeeze all the other planets of our solar system between Earth and the Moon. The average distance between them is about 240,000 miles. If you added up the diameters of the 7 planets, you'd still have some room to spare, about 5,000 miles. In 2011, scientists made a groundbreaking discovery of a massive reservoir of water in space. This water, equivalent to 140 trillion times all the water in Earth's oceans, could provide each person on our planet with a planet's worth of water 20,000 times over. This reservoir was located near a massive black hole drawing in matter and emitting energy, known as a quasar. The water was formed by energy waves colliding hydrogen and oxygen atoms together, and it was found around 12 billion light-years away. So, when the Curiosity Mars rover snapped its very first sunset picture in 2015, scientists were practically doing backflips from excitement. Turns out, sunsets on the red planet are anything but red. They're actually a stunning shade of blue. According to NASA, the reason behind this phenomenon is that the dust in Mars' atmosphere is like a magical filter that lets blue light shine through while blocking out those warm tones like yellow, orange, and red. Well, Venus is a slow spinner compared to Earth. It takes this planet 243 days to make a full rotation, and it spins in the opposite direction. But even though Venus takes longer to spin around, it zooms around the Sun in just 225 days because it's located so close. So, believe it or not, a year on Venus is actually shorter than its day. So, you might think that the night sky should be full of stars with no dark spaces at all. This idea is known as Olbers' paradox, named after German astronomer Heinrich Wilhelm Olbers. He thought that if the universe was infinite, unchanging, and timeless, then we should see stars everywhere we look. But it turns out that the universe is not infinite, unchanging, or timeless. Edwin Hubble discovered that the universe is actually expanding, and the leftover radiation from the Big Bang tells us that the universe is about 13.8 billion years old. Think of all the birthday candles. Ooh! So, the reason we don't see stars in every direction is because some stars are just too far away, or they haven't been around long enough for their light to travel all the way to us. During the Apollo 16 lunar mission, Ken Mattingly, the command module pilot, had a bit of a scare when he realized his wedding ring was missing. The whole crew frantically searched the spacecraft for it, but no luck. Finally, on day 9, while Mattingly was on a spacewalk, the ring was spotted floating out the hatch door. Charles Duke Jr. tried to grab it but missed. Luckily, it bounced off Mattingly's helmet into Duke's hands. It's cool they found the ring, but there are many other things people left up there. There's even a toothbrush floating around somewhere. Mercury is already the tiniest planet in our solar system, not counting Pluto, of course, and the second densest after Earth. And believe it or not, it's actually shrinking and getting denser. For a long time, scientists thought Earth was the only planet with tectonic activity. But that all changed when the Messenger spacecraft flew by Mercury, giving us a detailed scan of the whole planet. In 2016, Messenger discovered these cool cliff-like formations called fault scarps. Since they're still relatively small, scientists think they're pretty new, suggesting that Mercury is still contracting 4.5 billion years after the solar system began. And around 10 years ago, Australian astronaut Luca Parmitano went through a near-drowning experience during his spacewalk due to a water leak that went unaddressed. Nobody knew how it happened and why Luca ended up having water in his helmet. NASA was investigating the issue for months, but they were unable to determine the exact cause of the water entering Luca's helmet. While some astronomical events are pretty common, there are those which occur only once a year or once in 100 years. let's have a look at the coolest and rarest events we might be able to see with our own eyes. The first amazing celestial event on our list is the Perseid meteor shower that will take place from the 17th of July to the 24th of August 2024. This event is going to be one of the most vibrant of the year. At its peak, between the 12th and 13th of August, you might see up to 100 meteors per hour, if you're in a dark place, that is. This meteor shower is caused by debris from the comet Swift-Tuttle. As meteors streak through Earth's atmosphere, they often leave behind long wakes of light and color. The perfect time for watching this cosmic show is right before dawn. On the 2nd of October 2024, we'll be able to watch a ring of fire solar eclipse. Its scientific name is an annular eclipse, and it occurs when the moon is slightly farther away from our planet. In this case, when the disks of the moon and the sun align, the moon's shadow doesn't completely block the sun's light. As a result, you can see a ring of sunlight around the moon. This time, the ring of fire will be visible in southern Chile and southern Argentina, so book your flights early. Another cool event that will occur this October is the Draconid meteor shower. During this event, meteors are more likely to fly in the evening hours than in the early morning. This is usually a slow shower, producing just a handful of meteors per hour. On the other hand, astronomers speak of a rare fiery Draco, which has been known to send many hundreds of meteors across the sky within a single hour. Are we going to get lucky this year? Time will show. Starting from the 12th of October and for the following week, you'll have a chance to see a comet passing by our planet. Now, even though this nearly unpronounceably named big boy will be about 40 million miles away from the Earth at its closest point, you might be able to see it with the unaided eye. Now, comets have a reputation of being quite unpredictable. Most of these dusty, icy space bodies are thought to have originated on the outskirts of the solar system millions of years ago, and there they spent most of their time in the dark, inert and unnoticed, like me in middle school. Now, some of them come closer to the sun, and many experts already forecast a fantastic celestial spectacle in October. So if you missed the meteor showers we've talked about, you'll be able to catch up. Orionid meteor showers will keep going from the 26th of September till the 22nd of November 2024. Sometimes this event can produce from 40 to 70 meteors per hour, but recently the maximum number was lower, from 20 to 30 visible meteors. And the final event for this year is going to be the Geminid meteor shower. And let me tell you, this event is going to be breathtaking. Astronomers claim that this meteor shower is one of the best of the year because of bright visible meteors. Around 120 shooting stars are likely to streak across the sky per hour. Interestingly, while most meteor showers come from comets consisting of dust and ice, the Geminids originate from a rocky asteroid. Scientists still don't know how to classify this asteroid since it has a tail and brightens as it comes closer to the sun, just like a comet. On the other hand, recently, astronomers have discovered that the asteroid's tail is not made up of dust but of sodium gas. Alright, let's travel farther into the future. In 2029, we'll witness the darkest lunar eclipse of the century. A lunar eclipse occurs when our natural satellite completely hides in Earth's shadow. Sometimes, when it happens, the moon can look bright red. Normally, the closer the moon is to the center of the shadow of our planet, the darker the eclipse is. And, according to experts, the eclipse on June 26, 2029 will be extremely dark. It will last for about an hour and 42 minutes and will be the most visible in South America. So, again, don't forget to book your tickets. A supermoon that's also the second full moon to occur within 1 month is known as a blue supermoon. Such supermoons don't follow a regular schedule and occur every 10 years or so. According to NASA, the next blue supermoons will happen in January and March 2037. Then, 3 years later, in 2040, we'll witness the Parade of Planets, when 5 planets of the solar system, Mercury, Venus, Mars, Jupiter, and Saturn, will line up. Of course, it won't be a perfectly straight line, but it will still be a pretty impressive view. Some planets, like Venus and Jupiter, can be clearly observed even in big cities and with the unaided eye. But during the Parade of Planets, you'll be able to see more. So perhaps it's time to stock up on telescopes. The brightest supermoon of the 21st century will occur in 2052. The thing is, the orbit of our natural satellite isn't perfectly round. The moon follows an elliptical path while traveling around Earth. That's why there are 2 points closest to Earth, called the perigee, and the farthest, known as the apogee. On the 6th of December 2052, we'll see a stunning supermoon. Our satellite will be around 221,000 miles away from our planet, which is closer than normally. In 2060, we're likely to see a comet called 15P Finlay. It will be one of the closest comets to approach our planet in the last 100 years. It'll fly by at a distance of around 3.1 million miles. And here's the thing. Every time a comet comes close to the Sun, it heats up and starts emitting gases and dust, looking like a little star. Thanks to solar winds, it also gets a beautiful long tail. And the closer to Earth a comet passes, the brighter it looks in the sky. So get ready for a breathtaking show. In 2084, something known as an Earth eclipse will occur, becoming one of the most exciting events of the 21st century. Sadly, we won't be able to see this celestial spectacle from Earth, obviously, but we might be able to admire it from Mars. During this event, the Moon and Earth will pass by the Sun, looking like dark silhouettes. Such an event is known as a planetary transit, something like a solar eclipse but with other planets instead of the Moon. Now in 2100, for those of us still here, the North Star will be the closest to the North celestial pole. Sailors have been using this famous star for centuries to figure out where North is. But the funniest thing about this is that this star isn't perfectly aligned with North. The reason is that Earth doesn't have a fixed axis. It rotates in space like a giant spinning top in a process called orbital precession. That's why the North Star doesn't remain in the same place in the sky. It moves slowly but steadily. But on the 24th of March, 2100, the polar star will finally appear over the true north of our planet. And after that, it'll start moving away again, to return 26,000 years later. So as you can see, it's going to be a truly rare event. Plus, it'll be like a parting gift from the North Star. Since Earth's axis is constantly moving, in around 2,000 years, the North Star will be replaced by another, Gamma Cephalus. So the close approach in 2100 will be the nearest it will be to our planet for a long, long time. So I hope you've made notes of the most interesting astronomical events of the next 100 years. The coolest thing is that to witness most of them, you don't even need to buy a telescope. They're going to be visible to the unaided eye. Ooh, look at that! Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth, it's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri B. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri B is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri B's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet. Does the universe ring like a crystal glass? Maybe. But it doesn't mean that it literally rings and we just don't hear it. It just vibrates. Many of you know that the universe started with the Big Bang around 13.8 billion years ago. I wasn't around then, but we can assume. The whole enchilada was born from a super-concentrated, hot, and dense tiny dot that contained everything. When it couldn't bear its pressure anymore, it made a huge blast and spewed around all the time, space, matter, and antimatter like a Pokeball. After being born, the universe moved at a breakneck speed. Imagine standing in the middle of nowhere, you blink, and suddenly you're surrounded by the universe. That's what it would feel like. It started growing and growing, and eventually, its speed got slowed down a bit by gravity. Gravity started pulling all the matter together, slowly helping new things like stars and galaxies to form. Okay, makes sense so far. The Big Bang gave the universe a big push, accelerating it. Logically, everything should eventually slow down and start moving at a constant speed, or even stop, right? Well, nope. In the late 90s, astronomers discovered something weird. They looked at some supernova around us, and for some reason, these supernovas were super far away, much farther than they were supposed to be. In other words, the expansion of the universe is not only continuing after all these years, but it's even accelerating. After years of study, they discovered the concept of dark energy, a mysterious force that makes up about 68% of the universe's total energy. This energy pushes it to expand even faster over time. And now, scientists have proposed a new discovery. Perhaps the universe's movements are a bit, well, wobbly. It seems like the universe's expansion hasn't been smooth and stable over the years. Instead, it has undergone periods of speeding up and slowing down multiple times. Astronomers counted about 7 cycles of this acceleration and deceleration over the history of our universe. This can be compared to the oscillation of a crystal glass. When you strike a crystal glass, it vibrates, oscillating at its natural frequency. It goes through fluctuations in which the frequency rises and falls. Over time, it calms down and fades away. Well, something like this is happening to our universe. You can imagine its speed also fluctuating like that, rising and falling, first super rapidly and then more calmly. As if it's not just different waves traveling through it, but our entire world is like one huge ringing wave. The discovery was actually made by accident. Astronomers were working on dark matter modeling. They plotted a new graph called the Hubble diagram, which shows how big the universe got over the years, measured in supernovas. Supernovas are like some lighthouses of our world, helping us mark things on a map. That's when they found these oscillations. But we still need to check all the data to make sure that this discovery is indeed true. Dark energy and dark matter play this weird game with the universe, where one is constantly trying to pull everything together, while the other one wants everything to expand. So far, dark energy vastly outweighs dark matter, whose weight makes up only 27% of the universe. Now, both of them are invisible to us, and not just invisible to our eyes like infrared, it's that we literally can't detect them in any way. We can only assume that they exist based on how they influence gravity, changing entire galaxies, and all the large-scale structures of the universe. We basically made them up because it was the only way to explain how our world works. Dark energy is uniformly distributed across space and time, and we're still not sure what exactly it is. Some theories say that it could be a property of space itself, quantum fluctuations, or even a new type of field or particle. But all we have for now is an invisible energy that pushes the universe to move very fast. If one day we learn more about it, this will help us predict the entire fate of our world. Depending on how exactly dark energy works, the universe may continue expanding and growing indefinitely, or maybe one day it will experience the Big Rip, where all matter will be completely torn apart. Okay, here's to hoping we're not all around for that. Meanwhile, dark matter, also invisible and yet to be proved, works the opposite way. It's not energy that accelerates things. Instead, it's more like a glue that tries to hold everything together. It's a type of matter we can't detect because it doesn't emit, absorb, or reflect light. We don't even know what particles make up this thing. We still can't catch them. At first, we thought it might be made up of regular heavy particles, like the one that makes up our world. But after years of research, they haven't found even a single one. So now they think maybe it's actually made up of ultralight particles, millions of times lighter than anything we know, and because of that, we can't even notice them properly. So now, astronomers try to detect not the particles themselves, but waves that they could leave as they move through space. But we believe that it exists, because if it didn't, our galaxies wouldn't hold together. Dark matter helps them form, grow, and rotate. So, about 85% of our world is made of something unknown. All of this is incredibly mysterious and needs a lot of research. But that's what we know now. Maybe in the future, we'll discover something that will completely change our perception of the universe. That's what happened to Albert Einstein. In the early 20th century, most scientists, including Einstein, believed that the universe doesn't actually move. They thought it was static, neither expanding nor contracting. That's because, to us, it feels like it doesn't really move. Back then, scientists didn't have powerful computers or telescopes that could detect all the little changes in the positions of stars and supernovas. When Einstein developed his famous general theory of relativity in 1915, his equations actually suggested that the universe should either be expanding or contracting. This didn't really make sense to him. To fix this calculation flaw, he decided to introduce a new term, the cosmological constant. It was like a repulsive force that counteracted the attractive force of gravity. Essentially, it meant that while gravity tries to push everything together, some force or energy helps to balance this out by pushing everything apart. Sounds familiar? Then, in the 1920s, astronomers Edwin Hubble and Georges Lemaitre found out that the universe isn't static, it actually expands. They noticed a slight reddish tint from the distant galaxies, and this tiny hint meant that other galaxies were moving away from us. After that, Einstein scratched out the cosmological constant. Interesting how he was later ashamed of this assumption, calling it his greatest blunder. He didn't even know that he was 100 years ahead of his time, accidentally discovering dark energy. Now the cosmological constant is back again, just in a new form. Something similar happened with dark matter. Scientists have already started noticing that something doesn't add up back in the early 20th century. They saw that galaxy clusters didn't have enough visible mass to hold them together, which means there must be some unseen mass that helps to make up for it. And that's when it got its name, the dark matter. This stayed unresolved and unproven for many years. And then, it was finally discovered by Vera Rubin when she was observing galaxies and their movement. She realized that outward parts of galaxies move almost as fast as their central parts. This doesn't really make sense. The outer part should be a bit slower. This became the first official proof of dark matter, which boosted its research. There are still many things left to be discovered, but maybe one day we'll understand what is this invisible part of our universe that makes it ring.
Many sci-fi movies can make you believe that everything happening in space is accompanied by some kind of sound effect, which is a totally false misconception. In space, no one will hear you scream. There's no air in space. It's an almost perfect vacuum. And the sound waves don't travel through a vacuum. They can't reach your eardrums and make them vibrate, sending signals to your brain. But it's a good thing, especially for astronauts on spacewalks. If not for the quietness of space, they would be constantly overwhelmed by the noise of solar storms. Huge space explosions sure look super impressive. Whether they're scientifically possible or not is another question. Blasts on our home planet look the way they do because of air and gravity. You see, the air functions as an oxidizer, and the outward pressure makes everything fly into the air and then collapse back to the ground. But this process is very different in space, and it looks even cooler. If a blast occurred in space, there would still be some fire despite the lack of air, because some kinds of fuels can act as oxidizers. But it wouldn't be the fire you're imagining now. This cosmic fire would look like an expanding ball of light. It would be a seemingly never-ending process due to microgravity and the lack of air resistance. Nearby spaceships would be in grave danger since the shrapnel would fly outward until something eventually stops it. All comets have beautiful long tails. Huh? It's nothing but a popular misconception. In reality, comets are very difficult space bodies to spot. They usually spend large amounts of time far away from stars. There, in the darkness of space, they remain rather inactive and completely frozen. Comets only get tails once they come close to a star. That's when they start warming up. This process makes them form some kind of a cloudy atmosphere, which is called a coma, and a distinctive tail. The tail always points away from the star that influences the comet. It happens because the tail gets blown in the opposite direction by solar radiation and solar winds. That's why the tail can often be in front of the comet, not trailing after it. The inner and outer planets of the solar system are separated by the asteroid belt, a ring of asteroids and other debris and space objects orbiting around the Sun. While creating movies about space, filmmakers make sure to somehow use this region. Usually, they show the asteroid belt as an extremely crowded place with dense clouds of huge rocks you have to skillfully maneuver to get through to the other side. In reality, if you looked outside your spaceship while flying through this region of space, it would feel as if you're looking at the sky from Earth. All because of the ginormous distances in space. If you decided to cross the asteroid belt, there would be very little chance of a collision with a space object. Asteroids there are really spaced out and very far from one another. Black holes are giant, scary cosmic vacuum cleaners, they say. But in reality, black holes are more like fly traps. They don't look for things to munch on. Instead, they sit out there quite passively. Only when a star or any other object comes too close does a black hole spring into action. Even so, only those space bodies that cross a certain border get ripped apart. In fact, black holes aren't any different from any other celestial body since their pull is directly proportional to their mass. They can't swallow anything bigger than what their size allows. Even if our Sun was somehow replaced with a black hole as massive as itself, nothing would change for Earth or any other planet in the solar system. Gravitationally speaking, of course. Space battles in movies often involve using lasers. But if you were to see such a fight from up close, you would probably be disappointed. The thing is, it would be like nothing in movies. A laser beam is a concentrated burst of energy, and it could indeed be used for many purposes during a fight. But a real-life laser beam would be totally invisible in space, since there wouldn't be any particles around to scatter the light and make the beam bright red or green or any other color. A human would be torn into pieces if they got into open space without a spacesuit. Well, contrary to popular belief, taking off a spacesuit during a spacewalk wouldn't be as dramatic as it's often pictured in movies. A person would just lose consciousness due to a lack of oxygen after 15 seconds of being in outer space without protection. But that's if this person breathed out as much air as possible. Otherwise, this oxygen would damage their lungs from the inside, making them rupture. After that, without the protection of the spacesuit, the pressure inside their body would drop. This would cause even more serious trouble. And even though this person definitely wouldn't burst, they wouldn't want to stay outside for too long. People often believe that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon orbits Earth and the Sun doesn't float away out of our home Milky Way galaxy. Astronauts on the ISS do experience the effects of gravity, but that's not full-fledged. It's microgravity. The gravity on the space station is only 10% weaker than the gravity on Earth's surface, but astronauts are constantly in freefall. The spacecraft, people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they are very different things. A light year must mean time, right? Not really. Light years actually measure distance. NASA's definition of a light year goes like this: the total distance that a beam of light moving in a straight line travels in a year. And since light moves at a speed of 186,000 miles per second, a light year equals almost 6 trillion miles. It may seem as if the sun is always on fire. At least that's what it looks like in pictures and in movies. But in reality, our star is a giant ball of gas. Nuclear reactions happening in its core at all times make the sun burn. Every second, hundreds of millions of tons of hydrogen are converted into almost as much helium. During this process, huge amounts of energy are released as gamma rays. Then these rays turn into light. In other words, the sun does emit blinding light and incredible heat, but it's not actually on fire, because no oxygen is involved in the process. The speed of light is believed to be the ultimate barrier for people when it comes to space travel, and it's often thought to be impassable. There are many theories about what it might be like to reach that speed, but none of the equations account for going above it. And still, we know that at least one thing in the universe is faster than the speed of light: the rate of its expansion. Yep, the universe is expanding faster than the speed of light, baffling astronomers and casual sky watchers alike. Or at least we can say so in terms of the speed of different objects, like faraway galaxies relative to each other. At the moment, it's not something scientists understand well. The rate of the expansion of the universe is proportional to how far something is, too. The farther it is from us, the faster it's moving away. But even though we don't get the mechanics of it yet, we've got our proof, even though it's theoretical so far, that some particles might be able to travel faster than the speed of light. Some scientists think there could be more things out there in space that could challenge this speed barrier. All we need to do is find them. Is there a giant mega-sun in the center of our Milky Way? Scientists actually thought so for a while because it's the brightest place in the galaxy. It has millions of stars packed into a small area. This area is called the gigantic bulge. The gigantic bulge has millions more stars per light year than any other part of the galaxy. It can be 10 million times denser than our part of the neighborhood. In some cases, stars in this region are only 5 light days apart. That's like if there was another star in our solar system a bit further away than Pluto on a space scale. But why is this place so dense? When galaxies form, a lot of gas and dust come together under the force of gravity. This material gathers up and eventually forms stars. Gravity and angular momentum balance out, and it starts looking like a flat disk with a pretty bright, bulging, dense core. The stars live their comfy lives, and once they get to the finishing line, they collapse under their own huge weight. Then, the black hole forms. Black holes love to eat everything around them, and the more they eat, the bigger they get. And what place is more perfect for a fine dinner than the galaxy's center, where all the space stuff is packed together? So it starts eating surrounding gas and dust, forming an accretion disk. As this material spirals into the black hole, it heats up and emits a lot of energy, which makes the center of the galaxy even brighter. That's why you can find both supermassive black holes and galactic bulges in the centers of all galaxies. The galactic bulge at the center of the Milky Way looks a bit like an ellipse. That's a classical bulge. Stars aren't like our Sun. They move randomly in all possible directions and planes. Plus, they all move at different speeds. So gravity is going crazy there, and this makes the bulge look more like a sphere, or an ellipse. Since they were the first ones to form, they have some of the most ancient stars in our galaxy. But there are also some places of star formations and lots of younger, massive stars that are less than 100 million years old. As we move farther away from the center, things get a bit calmer. Stars start rotating uniformly and become stable. Right now, Earth is in one of the Milky Way's spiral arms called the Orion Arm, pretty far away from the galactic bulge. In our part of the neighborhood, stars are usually about 4 or 5 light years apart. This means that most of a galaxy is actually just black, empty space. Our black hole is called Sagittarius A star. It's a monster about 4 million times the mass of our Sun. It's also about 32 million miles in size, almost like the distance between Mercury and the Sun. But don't worry, it's not attracting the Milky Way inside it, and it's not going to eat us. These black holes are actually super small compared to the entire galaxy, so they can only eat whatever's around. Right now, many stars orbit Sagittarius A star, and even though it emits a huge amount of energy, we can't see its light from Earth without a lot of scientific effort. But why don't we see the center itself? The galactic bulge is so bright that even though it's 26,000 light years away, we should see it shining brightly in our sky. Yet, we don't. Turns out it's all because of space dust. There's a lot of dust between us and the core, and it absorbs most of the visible light. We can only look at the galactic core using other types of light, like near-infrared, gamma ray, and so on. NASA has images of the core in different types of light, and it shows how scarily bright the center is without the dust blocking our view. But not all bright regions are blocked by gas and dust. For example, when we look at dense clusters like the Messier 13, the stars are so close together that they look just like a white spot. Most of our telescopes can't separate them from each other. The satellite galaxy M32, our neighbor near the Andromeda galaxy, has about 84 stars per light year. It's so dense that stars can't be resolved even by the Hubble Space Telescope. To get the idea, our solar system is 2 light years long. We'd see about 168 stars outside our window if we were there. Our closest star is Alpha Centauri. It's about 4 light years away from the Sun. If it was just a couple of light days away, it would shine much brighter than the full moon. So if we somehow managed to survive in crazily dense star regions, the sky would be white all day long. But it's unlikely that we'd make it. As we get closer to the center of the Milky Way, the chances of finding life get super slim. The gravity of stars is going wild with chaotic movements, so there are barely any planets around. On those miracle planets, the radiation from cosmic rays is skyrocketing. Supernova blasts and star collisions nearby become an everyday occasion, and all the gas around makes it basically impossible to breathe or even see properly. At the same time, as we move further away, there are fewer stars around. Elements that are super useful for life, like carbon, oxygen, and iron, are produced by stars, so they also drop. Too much radiation is awful, but too low radiation means that there's not enough energy to support chemical reactions, like photosynthesis. Which is why, if there is extraterrestrial life, it would most likely be somewhere in the middle of different galaxies. But some galaxies get their brightness from a so-called active galactic nucleus. These are extremely energetic regions at the center of some galaxies. They shine much brighter than any stars imaginable, although it mostly shines only in certain parts of the electromagnetic spectrum. The brightness comes not from the stars, but from the accretion disk around their supermassive black holes. As the material slowly falls into a black hole, it gathers around it and creates this flat, spinning disk of gas, dust, and other stuff. Since the gravity and friction there are insane, this disk heats up and starts emitting enormous amounts of energy. Also, this disk spins incredibly fast, almost at the speed of light. Because of that, collisions there happen all the time, and they're unimaginably powerful. They release even bigger amounts of energy. Most galaxies don't have an AGN. Those that do, like the galaxy M87 in the Virgo constellation, are called active galaxies. There are also different types of AGNs: the Seyfert galaxies, radio galaxies, and finally, the winners of our space brightness competition, quasars. Imagine things so bright that they can outshine the entire galaxy they belong to. Quasars are a specific type of active galactic nucleus, the most extreme and luminous form. They belong to the supermassive black holes, the biggest ones in our universe. Quasars are like a combination of several things. First, they're the brightest accretion disks in our world, because of their behemoth black holes eating everything around. But they have some cool features. For example, they have powerful jets of particles that shoot out from the poles of the black hole at nearly the speed of light. These jets add up to the brightness of the quasar, although they can only be seen in radio wavelengths. The energy they emit is so intense that they can be seen billions of light years away. However, the nearest quasar to us is 600 million light years away, so we can't see them with backyard telescopes. So, when we look at a galaxy through a telescope, we usually see only the brighter core, not the outer parts. Unfortunately, our eyes just aren't made to see things like the active galactic nucleus. So, these stars are the brightest things we can see. But what a beautiful sight it is. In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way, as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our Sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found 2 supermassive structures called the Fermi bubbles and Rosetta bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them. A space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light-years away. Some think that this strange question mark is probably the result of 2 or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else: the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby, so what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and 1 billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists from the European Southern Observatory's Gaia mission spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest black hole to our planet ever discovered. The nearest one is called Gaia BH1. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of about 9.6 times that of the Sun. It means that it's way smaller than the newly found black hole. Gaia BH3 is located in the Agila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Okay, we can probably admit that this stellar black hole is just a small fry compared to supermassive black holes like the one that dominates the center of the Milky Way. I'm talking about Sagittarius A star. This space giant has a mass of 4.2 million times that of the Sun. While a stellar black hole forms when a star collapses, supermassive black giants have their own ways of seeing the light of day. They are usually the result of mergers of progressively larger and larger black holes. We'll talk about that later. First, let's speak a bit more about how stellar black holes form. When stars near the end of their lives, they typically inflate, lose a lot of mass, and cool to form what we know as white dwarfs. Such massive stellar black holes as Gaia BH3 are believed to form when a star doesn't contain heavy elements and loses not so much mass over its lifetime. Such stars are called metal poor. Afterward, instead of cooling into a white dwarf, this star collapses into a black hole. The companion of Gaia BH3 is a very metal poor star. It suggests that the star that collapsed and formed BH3 was metal poor too. Astronomers know of about 50 stellar black holes in the Milky Way. Some black holes are larger than others. You see, the universe is filled with black holes. Some of them are sprinkled randomly throughout galaxies. Others, those giants we know as supermassive black holes, sit at the center of galaxies. While stellar black holes are usually just a few times bigger than the Sun, such space monsters can weigh from 1 million to 1 billion solar masses. But even though they're so much heavier than our star, they're packed into a relatively small area. On a cosmic scale, of course, the size of our solar system or so. Some astronomers think supermassive black holes could form by several stars colliding and collapsing at once, while other experts state that such space objects might have started growing several billion years ago. At first, a small seed appears somewhere out there in space, which then gradually increases in mass to form a black hole. This seed does it through the process of accretion, which basically means gathering more and more matter around itself. Besides the absence of any precise information about the formation of black holes, there's also the black hole information paradox. If a black hole has some mass, and as we know, these spaced objects have a lot of it, then, according to the first law of thermodynamics, it should have a temperature. And according to the second law of thermodynamics, it should also radiate heat. Stephen Hawking showed that black holes are supposed to emit radiation too. These days, this kind of radiation is called Hawking radiation. It should form at the boundary of a black hole, but after proving it, Hawking pointed out a paradox. If a black hole is capable of evaporating, some of the information it contains can be lost forever. The problem is that the information contained in thermal radiation emitted by a black hole gets degraded. It doesn't repeat any information about the matter swallowed by a black hole before. Such an irreversible loss of information contradicts one of the basic principles of quantum mechanics. Physical systems that change over time cannot create or destroy information. It means we must be missing something. Both physicists and mathematicians have tried to come up with different ideas, but they ended with pretty weird results. Some have even claimed that the universe could be holographic. It means that the universe that we know and love is actually the result of some mysterious interactions at the infinitely distant boundary. I told you, black holes are really strange. At the same time, we have definitely found space objects that seem to have the properties of black holes. For example, look at this image of black hole M87 star. It certainly looks like a physical object, but what if black holes don't exist at all? There's an idea that black holes are actually gravastars, a blend of gravity, vacuum, and stars. This theory was first proposed in 2001 by Emil Matola and Pavel O. Mazur. They hypothesized that at one point during the collapse of a large star, intense gravity might transform its matter into a new state. It's similar to what occurs when atoms are cooled to such low energy states that they start acting like a single superatom. When we speak of gravastars, a star might collapse to the point of the event horizon, or the point of no return, and then its matter is transformed into a new state. It exerts enough outward pressure to prevent the star from collapsing into a physics-defying singularity. In gravastars, an ultra-thin, ultra-cold, and ultra-dark indestructible shell surrounds heavily wrapped space-time. This new form of matter turns out to be very durable, but it's also a bit flexible, like a bubble. So anything that's trapped by the intense gravity of a gravastar and smashed into it gets obliterated and then assimilated into the shell of this bizarre space structure. One of the benefits of the gravastar theory is getting away with those messy paradoxes connected with information and singularities. But even though this idea sounds kinda cool, it doesn't explain the phenomena we observe. And we've definitely observed something that looks like black holes. On the other hand, look at this shadow. It isn't caused by the trapping of light in the event horizon. It's a slightly different phenomenon known as the gravitational redshift. It makes light lose energy when it moves through a region with a powerful gravitational field. So, potentially, it could be a gravastar. When the light emitted from the regions close to the alternative objects reaches our telescopes, most of its energy is already lost to the gravitational field, which causes the appearance of this shadow. And still, like with black holes, things get complicated when you add rotation to the equation. Many experts are sure that gravastars would not be able to remain stable during rotation. But wait, it gets even more bizarre. There are suggestions that the insides of gravastars could contain a series of thicker shells. Those are known as nestars, something like a matryoshka doll. Of course, these theories aren't perfect yet. Astronomers still have a lot of work trying to build functioning models. There's also a chance that both black holes and gravastars exist. But then, we've got another problem on our hands. How can we distinguish between the two? Some theories suggest that these different kinds of space objects should also emit very different gravitational radiation. It could allow us to figure out whether we're looking at a gravastar or a traditional black hole.
Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors, like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life, with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot, known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendeleev's periodic table of the elements or those funky snacks you buy. Look at this exoplanet called K2-18b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things floating around in space but not orbiting around any star or brown dwarf. Instead of our Sun, K2-18b orbits a red dwarf called K2-18. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K2-18b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 19 trillion miles. Hey, you do the math. Hint, lots of zeros. K2-18b is a sub-Neptune, meaning that it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K2-18b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth and has an equilibrium temperature of 28 degrees Fahrenheit. Nope, it doesn't mean that K2-18b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Now, the trillions of miles that set us apart aren't a problem for potent telescopes, such as the Kepler Space Telescope that discovered this planet and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they had found water vapor in the atmosphere of exoplanet K2-18b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check. And plants love this stuff too, because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it. Without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K2-18b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide or simply DMS in the mix. On Earth, this stuff is usually linked to life, since it's normally produced by phytoplankton in the oceans. The fact that we're picking up hints of DMS on K2-18b is like finding a golden ticket in the cosmic chocolate bar. Hey, kinda gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet, playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean, with a hydrogen-rich atmosphere resembling a gas giant like Uranus or Neptune. Now this one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, it's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K2-18b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water-ocean thing is up in the air. Initially, we thought water in a supercritical state was most likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick. Others think a gas-rich mini Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found that K2-18b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K2-18b is just a small fraction of its total mass, around 6.2%, and has probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Now, besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with the temperature inversion causing a stratosphere situation, just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet, unless the planet is spinning super fast and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K2-18b gets from his star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's still hard to tell if there's life on K2-18b, because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect different markers of life on the planet with enough observations.
The Earth might be on the verge of a huge change. Scientists have discovered that every 200 million years, comets start raining down on our planet. This comet shower changes how the Earth looks, reshapes the continents, and increases geological activity everywhere. We are in the 20th cycle, which means new transformations are coming soon. Why does Earth have active plate tectonics and continents, unlike any other planet? To learn the truth, geologists decided to check out zircon crystals. We often find these tiny crystals in rock. They're very tough and can survive crazy geological processes that could destroy most other minerals. But they're cool because we can use them to learn how old their rocks are. These crystals have some uranium in them, and it decays into lead over time. By measuring how much uranium decayed in a crystal and how much is left, you can figure out the age of a mineral. So, we can use this trick to learn a lot about the Earth's crust and history. Recently, geologists checked out zircon crystals from two of the Earth's oldest continents and regions, the North American Craton in Greenland and the Pilbara Craton in Western Australia. It turned out that rocks from these continents could tell us what happened to our planet during the Archean Eon, from 2.8 to 3.8 billion years ago. It was a crazy era for our planet, back when magma, rich in elements we've never seen before, pierced the surface and broke out for the first time. This event changed what the land looked like forever. And when scientists studied them, they noticed something else. It looks like there's a cycle where every 200 million years the Earth starts forming new continental crust for some reason. When they explored this further, they suddenly realized that this might be because of our galaxy. Our solar system is located in the Milky Way galaxy, right here in the Orion Arm. An arm is a place that has tons of stars, gas, and dust. There are many of them in the Milky Way, bigger and smaller ones, and they extend and wind outward, making galaxies look like spirals. We're located in a minor arm, about 27,000 light-years away from the heart of the Milky Way, a horrifying black hole called Sagittarius A star. But our solar system doesn't just stay in one place. It moves at a breakneck speed of 150 miles per second. That's like crossing the Earth 22 times in an hour. Just like planets move around the sun, the solar system rotates around the center of our galaxy. This orbital period is called one galactic year. Objects that are closer to Sagittarius A star move faster. You know, your typical inner lane advantage. But large arms, the ones that are further away from us, are much slower. They move at a speed of about 130 miles per second. That's just some 19 runs around the equator in an hour. Because of this difference, the solar system moves kinda in and out of the galaxy's spiral arms. This is like when fans make a wave in a stadium. This leaves a mark on both the solar system and our planet. There is a vast, distant region around our solar system called the Oort cloud. It's about 4.6 trillion miles away from the Sun, like traveling to the Sun and back 50,000 times. Now, the Oort cloud is filled with comets. You might not know this, but they're way more dangerous to us than regular asteroids. Asteroids come in different sizes and are usually just rocks with some metals. They don't have a glowing gas around them. They just vibe around the Sun in their main asteroid belt, somewhere between Mars and Jupiter. And if the almighty Jupiter with its crazy gravity doesn't stop them, sometimes they come down on us, causing some havoc here and there. But a comet is a small object made mostly of ice and rock. When it gets close to the Sun, it heats up and releases dust and gas. This forms a glowing cloud around it called a coma. This is what we see as a tail as the comet moves, and their consequences are much more extreme. When we complete one galactic year, the icy objects from the Oort cloud are pushed towards all our planets. And when we enter the big spiral arms of our galaxy, the rainstorm begins. Comets are much faster than asteroids. When they hit Earth, they leave huge impacts and leave giant craters. The energy from these impacts can melt huge parts of Earth's crust and mantle. The molten rock then rises to the surface, floating there. As it cools, it solidifies and forms a new crust. Over time, these small pieces of crust can merge and grow larger as more solidified magma attaches to them. Eventually, all this forms big continents. So, once in a galactic year, when comets start hitting Earth more often, they really change the Earth's structure and help create new land masses. Another proof of this is spheroidal beds. This is what we call tiny round particles created by material thrown out during impacts. When we look at them, they also match the cycle timing. Spheroidal beds on our planets formed exactly when the Earth was crossing the Milky Way's spiral arms, and most of them formed when it was just over 1 billion years old. There are many cycles that influence our planet. For example, the Milankovitch cycles, the ones that tell us how the Earth's orbit and tilt change over time. This affects the planet's climate, but this new 200 million year cycle is a whole new level. We used to believe that continents only formed because of things that happened deep within our planet. And, well, maybe asteroids influence it a little. But now it seems like the continents were born and shaped thanks to the Milky Way itself. Scientists now want to study these ancient deposits to see if it's actually true. If it is, it could mean that we're getting closer to some huge geological activity. The continents might start reshaping again, or even coming together to form a new supercontinent. The continents on our planet look like puzzle pieces that fit very well, like South America and Africa. And that's not a coincidence. Many years ago, they formed one supercontinent called Pangaea. Pangaea used to be a landmass full of unique creatures, like the giraffe-necked Tanystropheus, the toothless Lystrosaurus, and the reptile bird Drepanosaurus. But the ground beneath us is always moving, floating on magma like vegetables flowing on a super hot soup. And eventually, Pangaea broke apart. However, it wasn't the only supercontinent in our history. This coming together and then breaking apart happens pretty regularly, like with some toxic people. Usually it happens every 200 to 600 million years. So yes, all our current continents will come together again one day. We call it Pangaea Proxima, Pangaea Ultima, or simply Amasya. It could form during the next galactic year. There are many theories about how it might happen. Africa might merge with Europe, and Australia might move north towards Asia. Life on Pangaea 2.0 would be challenging. People would likely have dark skin, hair, and eyes. We would all hang out near the equator and along the coasts, because the weather would be nicer and calmer there. The center would be horrifying, hot and dry, filled with deserts. There would be a common language and shared traditions. In general, such an event would really bring us closer together. No pun intended. However, it would also mean that if someone starts fighting, we're all screwed. Also, all the potential health issues might influence everyone on the continent. And let's pray that there won't be any large asteroids this time, or we're definitely doomed. This, of course, the movement of the Earth's crust will lead to a lot of cataclysms. But maybe humans won't even live on Earth by that time.
So Venus and Earth are so different that a foolish question like, what's longer, a day or a year, that makes absolutely no sense on Earth, totally makes sense on Venus. A day on Venus is indeed longer than a year. If we put it into Earth's perspective, a day on Venus would equal 243 Earth days, while a year would only last 225 days. So it's like your birthday is every day. Venus is often nicknamed Earth's evil twin. Their differences are so stark, you'd think they're from different galaxies altogether. Just to give you an idea of how far apart they are, if the day-to-year ratio wasn't enough, the Earth rises in the west on Venus but sets in the east. These days, one of the very few similarities between these two is their size. But try to imagine a time when Venus and Earth were like peas in a pod, besties since the beginning of the solar system. Venus used to be the life of the party. NASA scientists think Venus might have even hosted a liquid water ocean and surface temperatures that could have welcomed life for up to 2 billion years. But modern-day Venus is a different story. We're talking extreme temperatures and a thick carbon dioxide atmosphere. So, what led to this cosmic makeover? Size, location, and attitude. I mean that the distance from the Sun and internal heat played a huge role in shaping Venus and Earth's destinies. By the way, there used to be 3 siblings that could have hosted life: Venus, Earth, and Mars. Now imagine 3 cupcakes in an oven. Once they were fully baked, they were taken out of the oven. One of them was put in front of an open window in the middle of winter. Another was carefully placed on a table and covered with a nice clean kitchen towel. And the last one was accidentally forgotten and left in the oven. Oops. Mars, Earth, and Venus are like those cupcakes. Mars got too cold and not welcoming. Earth is still nice and warm and well protected from all the unpleasant things, just like the towel protects that lucky cupcake. And Venus got scorching hot and impossible to consume. In terms of development, Earth took the slow and steady route, maintaining its oceans, stable atmosphere, and biodiversity. Venus, on the other hand, cranked up the temperature, evaporated its oceans, and went all in with greenhouse gases. As a result, we have a planet where you'll melt faster than a snowman in July. Mars, on the contrary, will turn you into an ice popsicle within seconds. But chances are, it might have been pretty hospitable at some point. Some scientists believe that Mars used to be covered with flowing rivers and lakes and had no water shortages. Even today, Mars still has an ocean called Oceanus Borealis, or rather, the remains of what once used to be an ocean. It lost nearly all its water over time. Now, the sources of water on Mars include polar ice caps and minerals and rocks. According to estimates, only 1% of all that water evaporated, while 99% is still locked in the red planet. Ice polar caps are pretty simple to understand, as we have the same thing on Earth. But rocks containing water? Simple. There are at least 4 types of hydrous minerals on Mars. There are hydrous clays made of silicon oxygen, and the cool thing about them is that they can even contain magnesium and iron, which are sulfur-based hydrous sulfates. Now, don't you? I know you thought of the smell of rotten eggs. But it's typical of hydrogen sulfur and not just sulfur. These minerals have water incorporated right into their chemical formulas. There's also hydrous silica, which has water locked in its formula too. Scientists have experimented with growing plants using Martian-like conditions and found success with alfalfa. Harvesting alfalfa also helped improve the growth of other crops like turnips and lettuce. While water may be available on the red planet, the air on Mars is mostly carbon dioxide. On the bright side, and we are, the Mars Oxygen In Situ Resource Utilization Experiment, the Mars Oxy, can produce oxygen on Mars, which could be crucial for future missions. As for energy sources on Mars, solar, wind, and geothermal energy are a few promising options. Solar power is less effective on Mars due to weaker sunlight and dust storms. But wind power and geothermal energy could serve as reliable alternatives. With these sources in place, humans could potentially sustain life on Mars. But let's get back to comparing our sibling planets. While both Mars and Earth have moons, and Mars even has 2 of them, Venus has 0, just like Mercury. Due to its proximity to the Sun and the star's gravitational pull, Mercury lacks the ability to retain its own moon. The likelihood of any moon orbiting Mercury either colliding with the planet or being drawn into the orbit of the Sun is high. That's all clear and understandable. But the absence of moons around Venus remains an unsolved puzzle for scientists. Despite Venus's scorching hot temperatures, scientists think that even today it might not be as hostile to life as we once thought. A recent MIT study found 19 amino acids surviving in a Venus-like solution for the whole month. Yep, some like it hot. Also, Rocket Lab and the Massachusetts Institute of Technology are teaming up to send an uncrewed spacecraft, Venus Life Finder, on a mission to Venus. This spacecraft will search for signs of life in the Venusian atmosphere using a special instrument called an autofluorescing nephelometer. And no, I didn't make that up. Originally set to launch in 2023, the mission is now pushed back to December 2024 with arrival at Venus in May 2025. The goal of the mission is to discover organic compounds in Venus's atmosphere, which could point to the possibility of habitable conditions in the cloud layer. The spacecraft is designed with a Photon Explorer cruise stage and a compact atmospheric probe equipped with that nephelometer thingy. The small probe will descend through the Venusian atmosphere, collecting data on cloud particles and organic compounds. In 2020, scientists made a big announcement about finding phosphine on Venus, a compound that could be linked to life. While they're still working on confirming this, using information from telescopes or even past missions, there might be evidence hidden in old NASA data received from Venus that could shed more light on the discovery. The potential presence of phosphine on Venus has stirred excitement and caution among scientists. To make sure, they need more data from telescopes or new space missions. If they find this gas, it might mean there is some form of life producing it in the planet's clouds. This discovery would be a huge step toward understanding Venus better. Some experts think that sending probes to Venus to directly detect phosphine would be the most effective way to confirm its presence. An 80s NASA mission may have already detected phosphine, but scientists back then didn't realize it. Now, this data is being re-evaluated to uncover any overlooked evidence of the presence of the gas. This could also suggest that the compound has been in Venus's atmosphere for decades, raising questions about its source. But not everyone is convinced of this interpretation, which evokes a debate among scientists about the true nature of the detected gases. Old data from other missions may also hold clues about phosphate on Venus. While new spacecraft are going to explore the planet, it's possible that the key to unlocking this mystery lies in decades-old mission records. In total, there have been 46 space missions to Venus, including some flybys where gravity lent a helping hand. The last time we successfully landed a spacecraft on Venus was way back in June 1985 as part of the Vega 2 mission. So, let's see what Venus Life Finder will discover. Well, it turns out black holes might not be as elusive as we once thought. They might be hiding within stars. In this case, the extra mass of some of these space lanterns could explain weird gravitational effects in the universe. Previously, dark matter was the cause of these phenomena. The black holes I'm talking about might be those itty-bitty ones that appeared at the dawn of time when the universe was just a baby. And they may still be lurking in the hearts of giant stars. A team of scientists say the idea might be quite plausible. Astronomers could detect such trapped black holes by the vibrations they produce on their star surfaces. And if there are many of them out there in the cosmos, they might function as the very dark matter that holds the universe together. Almost any black hole was once a massive star that collapsed in on itself and became incredibly dense. Black holes have immense gravitational pull. Even light can't escape their clutches. People often think that black holes work like vacuums, pulling space inside. But that's not the case. Black holes can only swallow stuff that is extremely close, usually space objects venturing into their event horizon. That's a black hole's point of no return. Once you cross this border, there's no escape. In 1971, renowned physicist Stephen Hawking suggested another origin of black holes. If we took the thick soup of particles that appeared moments after the Big Bang and the birth of the universe, we'd be bound to find some spots dense enough to collapse and create black holes. Such holes, which got the name of primordial black holes, could range in size from microscopic to gigantic. If they were pervasive and numerous enough, primordial black holes could act as dark matter, knitting the cosmos together with their enormous gravity. And dark matter is believed to make up 85% of all the matter in the universe. So what's the matter? Astronomers have been searching for primordial holes by looking for flashes that would occur when they pass in front of distant bright objects, magnifying their light like a lens. But they haven't spotted even one yet. On the other hand, if a primordial black hole was tiny enough, with a mass like that of an asteroid and a diameter as minuscule as a hydrogen atom, the flashes wouldn't be bright enough to be detected by such surveys. Then the team, researching the phenomenon of primordial black holes, decided to consider the consequences of a universe where dark matter was made entirely out of tiny black holes. They concluded that one of such teensy holes could be dashing through the solar system at any given time. Some might occasionally get trapped within gas clouds, giving birth to new stars, ending up in their centers. The next step of the researchers was to build a model of a black hole existing in the very core of a star, where hydrogen atoms undergo fusion and produce light and heat. At first, they didn't see anything unusual. Even a super-dense stellar core is mostly empty space, and it wouldn't be easy for a microscopic black hole to find matter to consume there. That's why its growth would be incredibly slow. It could take longer than the lifetime of the universe for this tiny hole to eat a star. But what if a larger hole, as massive as the dwarf planet Pluto or asteroid Ceres, appeared at the center of a star? Then it would get bigger in a matter of a few 100 million years. The material would keep spiraling into the black hole, creating a disk that would heat up because of friction, emitting radiation. Once the black hole grew to the size of Earth, it would start emitting even more radiation, shining extremely brightly. It would also be churning up the star's core, and the star itself would turn into a black hole-powered rather than a fusion-powered object. Such entities were dubbed Hawking stars. To cool off, the exterior of a Hawking star would form a red giant. That's what our Sun is likely to turn into as it gets older. But a red giant star with a primordial black hole at its center would be cooler than the stars that have reached this stage through regular means. Such stars are known as red stragglers. To find out whether they indeed host a black hole, astronomers might need to tune into the frequencies at which stars vibrate. Since a Hawking star would mostly affect the interior of the star rather than its topmost layers, the star would thrum with a certain combination of frequencies. The waves created in the process could be detected in a way the star's light would pulse and throb. So, all scientists need to do now is study the already known red stragglers and figure out whether any of them show the characteristic vibrations of a black hole. Now, should we worry about the Sun? Since our star hasn't reached its red giant stage yet, we can't know whether it'll turn into a cool red straggler. What we know, though, is that our star might contain those tiny black holes that formed in the Big Bang. But now, we have no means to check whether they're indeed there. Currently, our star is around the midpoint of its existence, middle-aged. It creates energy non-stop by fusing hydrogen atoms within its core. Once it runs out of hydrogen in its core, it will enter its red giant phase and begin to collapse. It'll happen in about 5 billion years, don't hold your breath, and the phase itself will last for 1 billion years or so before our star depletes its fusible materials and loses its outer layers. It will leave behind a tiny white dwarf star half as massive as the Sun and around the size of our planet. In some cases, when the gravitational collapse of a star's core is complete, the star remnants turn into a black hole. But that's not the fate awaiting our Sun. You see, our star just doesn't have what it takes to become a black hole. It's not heavy enough. There are a few conditions that can affect whether a star can turn into a black hole, including its composition, rotation, and the processes that lead to its evolution. But the main requirement is still the right mass. Stars with 20 to 25 times the mass of the Sun can potentially experience the gravitational collapse needed to form black holes. In other words, the Sun is simply too small to form a black hole. But what would happen to us if it did? You might assume that if the Sun turned into a black hole, our planet would be doomed to be pulled into it. But do you remember the basics? Black holes aren't giant space vacuum cleaners, just sitting there and waiting for a new planet or star to get their hands on. Mwah. But black holes don't have enough gravitational force beyond that created by their incredible mass. And if the Sun were to turn into a black hole, which will not happen, this hole would still have the same mass as our former star, and Earth's orbit around this newly formed black hole wouldn't change. But all other things would change dramatically. The Sun, which is currently around 432,000 miles in radius, would shrink to a mere 1.9 miles in radius. But you wouldn't be concerned with the absence of the bright yellow sphere in the sky, since you have many more pressing issues on your hands. Our planet's main heat source would be gone, leaving us frozen in the dark. Without this source of energy, photosynthesis would immediately stop, disrupting entire food chains. Eventually, all life on Earth would be extinguished. But rest assured, our hard, barren rock of a planet would continue in its orbit. Oh well. Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the Sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the Sun, it sped up, like it had a rocket on it. And it wasn't the Sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space. You know what? 8 out of 10 people worldwide can't see the Milky Way anymore, and in just 100 years, it might turn into a forgotten tale from the past. It's not that the galaxy is disappearing, but that the cosmos is fading from view. Back in our grandparents' day, they could look up and see this vibrant tapestry of stars. But nowadays, we're lucky if we can even count them on one hand. This has nothing to do with nature. It's all because of the creeping threat of something called light pollution. Next time you walk around a big city after dark, take a moment to notice the large number of street lights, neon billboards, and office buildings shining all night long. Those endless city lights create an artificial brightness that competes with the natural glow of the stars. This is light pollution, and it's getting worse. Every year, Earth gets 10% brighter. That means if someone is born today in an area where you can typically see around 250 stars, when they reach 18, they'll only be able to see about 100 of them. Unfortunately, that's already a problem in big cities, where looking up at the stars is becoming something that you can only do in planetariums. It's gotten to a point where, during an earthquake that knocked out the power in Los Angeles in the 90s, many residents called emergency centers to report a massive silvery cloud in the night sky. But what they were actually seeing, perhaps for the first time, was the Milky Way. When you look at Earth from space, you can see vast areas of North America, Europe, the Middle East, and Asia all lit up. Singapore, Qatar, and Kuwait are some of the most light-polluted countries. On the flip side, remote places like Siberia, the Sahara, and the Amazon rainforest are in total darkness. Light pollution shows up in many forms. First, there is glare, like when you're driving and those bright lights literally make your eyes hurt, leaving you very uncomfortable. Then there is clutter, like Times Square with its crazy mishmash of different bright lights all over the place. Light trespass is when light sneaks into places it shouldn't, like a streetlight shining right into your bedroom. And finally, there is over-illumination, which is just using way too much artificial light for no good reason, like keeping all the office lights on throughout the night when no one is even there. All these forms of light pollution aren't just stealing the beauty of the night sky, they're also interfering with astronomical studies. When we rely too heavily on artificial lights, it messes up the work of Earth-based telescopes. And when that equipment can't do their job properly, we end up needing even more expensive space telescopes like Hubble and James Webb. And let's face it, that costs us billions. Turning night into day actually affects all of us, not just astronomers. Nighttime light messes with our sleep schedule and our body's internal clock. This clock keeps things like brain activity, hormone levels, and cell functions on track. So when it's disrupted, it can lead to serious issues like depression, insomnia, heart problems, or worse. One key process that gets messed up is the production of melatonin, a hormone that kicks in when it's dark. Too much light at night lowers melatonin levels, leading to stress, anxiety, headaches, and sleep deprivation. Blue light is the main villain here. You might think that turning on night mode and getting that orange glow in your phone screen is enough, but it's not. Blue light is also present in LED bulbs, the kind we use at home and in city lighting, because they're cheap and energy efficient. My point is that blue light is basically everywhere, and it's a real challenge to avoid it completely. This is also a big part of why we're not entirely sure how bad light pollution is nowadays. I mean, some statistics suggest that this issue increased by 49% over 25 years, up to 2017. But the real figure may be even higher. The thing is, blue light has shorter wavelengths, And the satellites we depend on today struggle to detect it accurately, meaning they don't quite capture the full extent of the light pollution caused by LED lights. Animals are lost and confused too. Their sleep patterns are also affected. A study from Germany revealed that blackbirds in urban areas are getting active much earlier than those in natural habitats. They wake up and start singing up to 5 hours sooner than their country cousins. Migration behaviors are messed up, especially for birds like sparrows and thrushes who travel at night. You see, they rely on the moon and stars as their internal GPS. So you can imagine how disoriented they get when they spot something like Las Vegas's massive sphere, lit up by 1.2 million LED bulbs. The intense brightness hides stars and disrupts their navigation across thousands of miles and continents. And it's not just that. Artificial lighting is unfortunately causing more birds to crash into skyscrapers and high-rise buildings. Insects, like mosquitoes, are also affected by light pollution. Yep, they're kind of gross, so it might not bug you if they're attracted to artificial lights and meet their fate. But remember, they're a crucial food source for many animals, like bats or frogs, so disrupting their populations could throw off entire food chains. Nighttime lights are causing problems underwater as well. Marine creatures near brightly lit panels off the Welsh coast are changing their behaviors, and fewer sea squirts and sea bristles are hanging out near those lights. Another example involves sea turtles. They typically lay their eggs on beaches and often return to the same spots for years. But when those beaches are too bright at night, female turtles might become confused and decide not to lay their eggs there. Now, do we really need all this light? It's hard to say. Some people might feel safer at night, while others think the opposite. You see, it's usually the glare that messes up our sight. Here's an example. If there's a super bright lamp blocking our view, say at a gate, we can't see anything but the light. But check this out. If we partially cover the light with our hands, suddenly we can spot an intruder. Wow. What I mean is that more lamps don't always mean more safety. It's all about using them the right way, and doing things like dimming lights can actually enhance security. Plus, it could save you some cash. Speaking of which, light waste has a pretty big impact on the economy. Take a Cobra Head streetlight, for instance. The light projected directly by it is only 30% of the total light it emits. In the US alone, roughly 1/3 of the light at night goes to waste, and that adds up to a staggering annual cost of $2.2 billion. Electric lights aren't all bad, of course. They have done some good stuff for us, like making our days longer so we can get more done and have some fun after work. But we can totally minimize this issue. Turning off all the lights would be awesome, but let's be real, that is very difficult, if not impossible these days. So, what can we do? Get those fancy controls like dimmers, timers, and motion sensors to make sure our lights are super efficient. Go for warmer colored lamps instead of those harsh blue ones. Oh, and consider using fully shielded light fixtures, like those cool vintage table lamps. They direct the light down where you need it, so you don't get that annoying glare or light scattering everywhere. Plus, when you cut down on wasted light, you're not just helping out the planet, you're also saving some cash on your electric bill. Talk about a win-win!
Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's Great Red Spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the near future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level parallel to the ground so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be on edge in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought. They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mentioned the presence of a giant spot on Jupiter too. If it was the same Great Red Spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 300 to 400 mile-per-hour jet streams. But like any other storm, the Great Red can't keep raging forever. It's been shrinking for a long time. In a decade or two, it's predicted to turn into GRC, the Great Red Circle, and who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 35,000 miles across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 10,150 miles, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet sitting over 3 billion miles away from Earth in the region of the Kuiper Belt drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving further away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects, just like the Sun, they were still sure that stars went through major changes extremely slowly, on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the Sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they're hoping to find a star that was steady and present for a long time, and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggest that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate. But Vasco is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny, tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other super-dense objects, like white dwarfs, and neutron stars or galaxy clusters. It means that any super-dense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe and its and our future.
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our Sun, the faster it became, releasing that hydrogen and also changing its path to our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos